Alright, so we're continuing on in Chapter 7 with Chapter 7.2, and this is still dealing with solving systems of equations and inequalities. Now what we're going to be dealing with here is kind of two variables, what they're going to call this Chapter 2 variable linear systems, and really what we're talking about is using elimination. Solving systems of equation by elimination. Now we solve a system of equation by using elimination. We want one of the variables to be the same in both equations, and when I say be the same, I mean have the same number. It doesn't have to have the same sign, but we need the same value. So 3x and 3x, or we could have had 5y and 5y. We need one of them to match up, because when we get one of them match up, we will eliminate it from both equations. Now we've done this method and used this method of elimination in Algebra 1 and Algebra 2. You've done it a little bit in Algebra 1. We did it more in Algebra 2. But this is an effective method for solving systems of equations. So they have this here, and you can pause it and read through it, but really what we're doing is we're going to set one of the coefficients of x or y to be the same in both equations, and if the signs are the same, we will if the signs are the same, we will subtract. If they're opposite, we will add. Here it's going to be making them so that the signs are the same, so that they differ, so you would add every time. But really, if the signs are opposite, we add. If they're the same, we subtract. And then we solve to obtain one of the variables, and then we plug it back in, or back substitute. So when we look at this here, really what we want to do is we want one of the variables to be the same. We want one of the coefficients in front of the variables to be the same. Now it doesn't matter if we pick x or we pick y. We can pick either one. Now looking at this here, it would be easier to solve this one for y, because if I solve this for y, I just need to multiply the bottom equation by 4. So that's what I'm going to do. I'm going to multiply this bottom equation by 4. So we're going to do 4 times our 5x plus y is equal to negative 1 times 4. We're going to multiply both sides by 4. And when we do that, 5x times 4 is 20x. 4 times y is plus 4y is equal to negative 4. And again, the reason we do that is because when we set it next to our original equation, or our equation on top, 2x minus 4y equals negative 7. And this equation here, paste it over here, the y values are the same. So we can use this elimination to cancel those out so that we have an equation with only one variable. Because again, even though I didn't say this at the beginning, we can only really solve one of these equations or solve any sets of equations or systems for one variable at a time. So we use elimination so that we can eliminate one of the variables out. So here we use it and we would add because the signs are opposite, and we have 2x plus 20x, which gives us 22x. Negative 4y plus 4y, these would cancel, giving us negative 7 plus negative 4 gives us negative 11. So now we have an equation with only one variable, and we can solve this. Because if I want to solve this here, the next thing I'm going to do is I'm going to divide both sides by 22. And when I divide both sides by 22, I get that x is equal to negative 1/2. And now 11 over 22 will simplify to negative 1/2. And now I've found the value of x. And what we can do now is we can plug it back in. Now we could plug it into this equation here, or one of these two here. It doesn't matter which one we use. I'm going to go on and just use the top equation. 2x minus 4y equals negative 7. I'm going to plug negative 2 back in for x, or negative 1/2 back in for x. So we get negative 2 times. So when we plug negative 1/2 back in, we get 2 times negative 1/2 minus 4y equals negative 7. And again, here we have an equation with only one variable. Well, 2 times negative 1/2 gives us negative 1 minus 4y equals negative 7. Now at this point here, I can add 1 to both sides. And when I add 1 to both sides, we get negative 4y equals negative 6. And at this point here, we can divide both sides by negative 4. And when I divide both sides by negative 4, I get y is equal to, well, a negative and negative make a positive, and we get 3/2 when that reduces. So our solution for this here is negative 1/2 comma 3/2. And at this point here, I can plug it back in, but this here will be our solution. And that's all we have to do here to find the solution of this system of equation. And this should be very familiar to you. We've done this before, you've done this before, and hopefully this was just kind of a refresher into what we do. And this here, so again, they set one of them, they set the bottom one, y equals, they substituted and found the value of x, and then plugged back in, found the value of y. Now we can plug it back in here, and they went on and checked it for us. They plugged the values in, and we found out that yes, it works. And with the other one, it works as well. So this is the solution. Now in the example, the two systems equation, the original system and the system obtained by multiplying by a constant are called equivalent systems because they have precisely the same solution. They have the same value. We've just increased the values. We just had a scalar applied to them. Now the operation can be performed a system linear equation to produce equivalent systems are interchanging two equations, multiplying an equation by a non-zero constant and adding a multiple of one equation to another, just like what we did. Now we're going to do one more example just kind of so you can see this here and work with this. Now this one here, so we can do this with decimals. So we can work with decimals and still work out and still find a solution for this here. So these are our two equations. Now if we look at this here, neither one of these really match up where we had y by itself. So I'm going to have to adjust both equations. Now I can adjust it for x or y. It doesn't matter which. Now I can solve for x first. I can make the values of x be the same. And to do that, I'm going to multiply the top equation, both sides. I'm going to multiply the whole thing. So here I'm just going to put one set of parentheses around, actually, I take that back. I'm going to rewrite it out, and we're going to multiply the top equation by 3. So I'm going to multiply the left and right side by 3, so 0.02x minus 0.05y by 3, and our negative 0.38 by 3. We're multiplying both sides by 3. And if we do that here, we get 0.06x minus 0.15y is equal to negative, make sure I do this right, negative 0.38 times 3 will give us negative 1.14. And that's one of our equations. Now we'll do the same thing with the bottom, but this time we're not going to multiply by 3, but we're going to multiply the bottom equation by 2 so that the values of x will be the same. Or multiply both sides by 2. And when we multiply both sides by 2, we're going to get 0.06x. So as we see here, the x values have the same coefficient, plus 0.08y equals 2.08. So now we have the same two equations, and we can put them over the top of each other. And now that we have one of the variables matching up, so the 0.06x in both of these here, we can use our elimination method to solve it. Now because the signs are the same, we're going to subtract. If they are opposite, we would add. Because they're the same, we subtract, so these two here will cancel out. And what we have is negative 0.15 minus 0.8. And we can do this in a calculator, negative 0.15 minus 0.08, which will give us negative 0.23y is equal to, so we can do negative 1.14 minus 2.08, and we'll get negative 3.22. And last but not least, to solve for y, we're going to divide both sides by negative 0.23. Negative 0.23, and when we divide both sides by this value, so we can plug this in a calculator, negative 3.22 divided by negative 0.23, and when we do this here, we get that the value of y is 14. We get that the value of y is 14. Now I'm going to grab this equation here just because I have it as a whole. And what we'll do here is we'll take this equation and plug in for y. So we'll get 0.06x plus 0.08 times 14 is equal to 2.08. 0.06x plus, well, I can do 0.08 times 14. I can multiply those two together, and we get 1.12 is equal to 2.08. And again, so we're still solving for x, so we need to get it by itself. So I'm going to subtract 1.12 from both sides. And when I subtract that from both sides, I get that 0.06x is equal to 0.96. And last but not least, we can divide both sides by 0.06, or 0.06. And we find out that the value of x is 16. So our solution for this here is 16, 14. And that's all we have to do for this problem here. Now, if we really wanted to, we could have multiplied this by 200 or 300 and moved the decimal place out, and it would have done the same thing. So we didn't have to deal with the decimal if we didn't want to. And I will show you that here, what I mean by that. So I still would multiply the top equation by 3, but I would multiply it, instead of 3, I'd multiply it by 300. 0.05y is equal to negative 0.38. And we're multiplying both sides by 300. Now we multiply by 300. Well, 300 times 0.02 is 6x minus 0.5 times 300 is 15y. Our negative 0.38 times 300 is negative 114. So if you notice, it's the same numbers, just we don't have the decimal anymore. And we could do the same thing with the other equation. Instead of multiplying it by 2, we'll multiply it by 200. X plus 0.04y, 0.04 times 200. And we multiply it by 200, we would get 6x plus 8y equals 208. So we could use that to move the decimal place away and move it out, so it's easier to work with. And we take these two equations, take the whole thing, here, and here, we would do the same thing. So we can use our elimination step. So we would subtract, because the values in front of x, the signs are the same, so that we need to subtract for them to cancel. And then we'd have negative 15 minus 8, which would give us negative 23y is equal to negative 322. So negative 114 minus 208. Sorry, it's not 322, it's negative 314. And then again, we can divide both sides by negative 23. And y will equal 14. And then we can plug it back in and see that x is equal to, I believe it was 16. So our answers were 16 and 14, and we get them here Still, it's just that we deal with whole numbers instead of fractions, or sorry, not fractions, decimals. So we can deal with whole numbers instead of decimals, and it'll work just fine. What we're going to look at next is graphical interpretations of solutions, and it's kind of looking at the graph and how they work. Now we'll have three different types that we could have, or kind of solutions that we could come across. One, there's exactly one solution, so two lines intersect at a point. The second is that they're infinitely many solutions. Essentially what it's saying is that those two equations are the same line. If there's infinitely many, it means the two equations form the same line, or there are no solutions at all. Now a system of linear equations considered consistent is consistent when it has at least one solution. So if it has at least one solution, it's consistent. I'm going to skip this for now, and it's considered inconsistent when it has no solutions. Now a consistent system with exactly one solution is independent, and when there's infinitely many, it is dependent. So we're going to look at these three here. Match each system of linear equations with its graph. Describe the number of solutions and state whether the system is consistent or inconsistent. So we need to match it up. Now what we could do is we could go and graph these here and see which one works and matches up. Or we can go on and work it out and see. Now all three of these here have 2x minus 3y, 2x minus 3y, 2x minus 3y equals 3 on all of them. So this line here, so I'm going to grab my highlighter. So these three here are all going to be this line here. So all of them are this line here. Now what we can do is we can see which ones the other equations match up to be. Now here we can add 4x and then divide by 6. So if I add 4x, I get 6y equals 4x plus 6. And when I divide everything by 6, we get y is equal to, well, 4 divided by 6 is 2/3 x, and 6 divided by 6 is 1. So y equals 2/3 x plus 1. So the only one where that crosses at 1 is here. So the first one matches up with this equation here. And because these two equations, as we see the graph, do not intercept, this one is inconsistent. So A would be inconsistent because the two graphs do not cross. They do not intersect. There is no solutions for those there. Now if we look at the second one here, well, I can subtract x and we get 2y equals negative x plus 5. Then we can divide by 2 and I get y equals negative 1/2 x plus 5/2. Now it's going to work out to be this one here because again our negative slope means that it's going down. As we go from left to right, it will be decreasing. And this is the only one where it will be decreasing. So B is 3 i's. I. Now this will have one solution and it will be consistent. So it's consistent because it has one solution, and we would consider it independent because it only has a solution. Now just because of elimination, it means that this one here is I. So it's still consistent, but we consider it dependent because it has an infinite number of solutions. And that's all we're going to do with this here. Chicopee, Massachusetts to Salt Lake City, Utah in 4 hours 24 minutes, and on the return flight it traveled the distance in 4 hours. Assume the airspeeds and the wind is constant for both of these here. So our two known unknown quantities are wind speed and the plane. Now R1 minus R2 would be the plane against the wind, and R1 plus R2 would be with the wind, because the wind would be either subtracting from it or adding to its overall speed. So we'd have our two equations here, and we're keeping the time in hours. So we'd have 2,000s equal our rate, so R1 minus R2 times 4 plus 24 over 60, and our other one, R1 plus R2 times 4. Now they simplified the equation, so this one here they divided both sides by 4, and here they simplified both sides, 4 plus 24 over 60, and ended up getting that 5,000 is equal to 11R minus 11R. Here, And what they'll do is we'll go through and solve this here. So they're going to multiply the bottom equation by 11 and then add the two together. They're adding these here together. So we add them together and get this here. And when we divide both sides by 22, we get that the speed of the plane is 477.27 miles per hour. Then we can plug back in and solve for the speed of the wind, and we get that it's 22.73 miles per hour. And that's all we'd have to do for this here. And here's the assignment for this one here.